Okay, so let's apply what we learned from our last lesson. If you remember, in our last lesson we discussed how to take a triangle and find our 6 trig function values, which are sine, cosine, tangent, and then the reciprocal functions, cosecant, secant, and cotangent, and how to find those trig ratios from a right triangle. Today we're going to apply that information. Given that theta is an angle in standard position, and this terminal side passes through point P, find the 6 trig function values for theta. So here's our drawing that we're dealing with here. Of course, here's the x-axis, here's the y-axis, and we are on the circle. Point P is where your terminal side and the circle intersect. Remember, in geometry you learn the definitions of a circle is the set of all points equal distant from a given point called the center. Okay? And so we have point P that's sitting out here. So that's at 3, 4. All right? Now, if the angle is drawn in standard position, that means its initial side is on the positive x-axis, and of course its terminal side, as you can see, is in quadrant 1, because the point 3, 4 would exist in quadrant 1. That means we're going to go 3 units to the right, and we're going to go up 4 units. Okay, now you would think that if I wanted to, for example, draw a triangle in this, that I would be using the y-axis, but you're going to see that's not what we're going to do. Now remember, our 6 trig function values are based on a right triangle, so you may be wondering, where's the right triangle? Oh, I see, we'll put it right here. Well, that's not really a good place. The origin isn't, because remember, our angles have to rotate around the origin, okay? So what we're going to do is we're going to take this vertical component and we're going to move it out here. So as you can see, there's my right triangle, there's my 90-degree angle, because when x and y intersect, it forms a 90-degree angle. Okay, so here's my y component, which is 4, my x component, which is 3, and there's a distance here from the center of the circle to the circle itself, and that's called my radius, which is r. Now the question is, how do I calculate r? Well, let's go back. We learned in geometry, Pythagorean's theorem, that basically said the sum of the two legs, the areas of the two legs, is equal to the area of the hypotenuse. In algebraic terms, a squared plus b squared equals c squared. Well, we kind of translated that to, if you remember, x squared plus y squared equals r squared. Now using that information, we now know that x is 3 and y is 4. And so we simply plug this in. 3 squared plus 4 squared equals r squared. So 9 plus 16 equals r squared. 25 equals r squared. So 5 equals r now. So my radius is now 5. Now the next question comes up, okay, then how in the world do I have my 6 trig function values? Well, let's go ahead and list them. We have sine of theta, cosine of theta, tangent of theta. Now we learned that sine was opposite over hypotenuse. Okay, I don't think anyone would disagree with that. So my angle is located right here at the origin. That makes the 4 the opposite side, and my hypotenuse would be my radius, which is 5. So this will become y over r. Okay. My cosine of my angle is adjacent over hypotenuse. Once again, my adjacent is my x, so this will become x over r. And my tangent, of course, was opposite over adjacent. We already know that opposite is y, adjacent is x, and so we have y over x. Now let's plug in our values and see if we can finish this up. Sine is opposite over hypotenuse, or y over r, so it's going to simply be 4 over 5. Cosine is adjacent over hypotenuse, or x over r, so it's going to be 3 over 5. And tangent is opposite over adjacent, so it's y over x, or 4/3. Now we also learned our reciprocal functions. Cosecant is the reciprocal of sine, so it would be r over y, or 5/4. Cosine is the reciprocal, secant is the reciprocal of cosine. So it's going to be r over x, or 5/3. Tangent would be the reciprocal, cotangent, would be the reciprocal of tangent. And so that's going to be x over y, or 3/4. So there are the 6 trig function values for the coordinate point 3, 4. Now let's extend that a little bit. What if I move down here to a quadrant 3 angle? What would be different about this? Well, once again, we notice that we have an angle all the way over here in quadrant 3. So remember, our initial side has to be on the positive x-axis, and we're coming all the way to the 3rd quadrant. Okay, so that's my theta. But remember, I need a right triangle in order to find my trig function value. So sure enough, here's my coordinate point. It's located at -3, -2. That's point P. So I can draw that right there, and there's my right triangle. But what is this angle right here? This angle that's formed by the negative x-axis and my terminal side? Well, eventually we're going to call this alpha. Alpha is going to be our reference angle. Now, a reference is something that you use to help you determine a value or help you figure something out. So here theta is my big angle that's between 180 and 270, and alpha is that reference angle that I'm going to use that's in my right triangle. Okay? Now what do we know? We know that the x is 3 and my y is 2. Now we know since we're going in a negative direction, I'm going to put the negative out front here, and you'll see why in just a second. Once again, how do we find my r, which is right here? Well, x squared plus y squared equals r squared. So x is -3 squared, y is -2 squared, and that equals r squared. So we're going to get 9 plus 4 equals r squared. 13 equals r squared. So the square root of 13 equals r. Okay, now once again, -3 squared is positive 9. We should know that by now. Alright, so here we go. Sine of theta is equal to what? Y over r. Cosine of theta is x over r. Tangent of theta is y over x. And let's see if we can find those three, our big three. Well, y is -2 over r, which is the square root of 13. Cosine is -3 over r, which is the square root of 13. And tangent is y, which is -2 over -3. Now we know that we can't leave a radical in our denominator, and this is one of the bigger skills in trigonometry that we need to learn how to do. And so we're going to multiply numerator and denominator by the square root of 13. It's called rationalizing the denominator. And we end up with -2 square root of 13 over 13. So there's my sine value. My cosine, for the same reason, multiplying numerator and denominator by the square root of 13. We're going to get -13 square root of 13 over 13. And my tangent is 2/3, because a negative divided by a negative is a positive. Now notice, my sine and my cosine are both negative, but my tangent's positive. That's interesting. So in the third quadrant, my tangent is positive, but sine and cosine are both negative. That's going to become important in just a minute. But let's finish up our problems. We've got cosecant. Cosecant's the reciprocal of sine, which would be r over y, which is going to be the square root of 13 over -2. We've got secant, which is r over x, which is the square root of 13 over -3. And we've got cotangent, which is x over y, which is going to end up being -3 over -2, which is 3/2. Now notice again, two of our trig function values are positive, tangent and cotangent. But the other four are negative. Sine is negative, cosine is negative, cosecant's negative, and secant's negative. Now, what will that do for us? Well, believe it or not, there is a very simple thing that you can learn that will help you determine which trig function values are positive in which quadrants. And it's very simply, all students take classes. Okay, I'm going to say that again. All students take classes. Okay? In the first quadrant, all of your trig function values are positive. In the second quadrant, only sine and its reciprocal are positive. In the third, tangent and its reciprocal cotangent are positive. And in the fourth, cosine and secant are positive. Now what that means is the other four trig values in quadrants 2, 3, and 4 are negative. Now why is that? Well, the best way to learn this is to understand the relationship of what is sine and cosine. Sine and cosine is the basic building blocks for all of your trig functions. Okay? We have learned that sine is y over r, cosine is x over r, tangent is y over x. Cosecant is r over y, secant is r over x, cotangent is x over y. Now, what if we go into the unit circle, meaning we don't care what the radius is, we're just going to look at the basic unit circle, meaning just our radius is 1. That means then that my radius would become 1, so my sine would actually equal y, and that's very important. And my cosine, if my radius is 1, would actually become x. So we can actually come up and say this: what's true for x and y with respect to sines, positive and negative, is also true for cosine and sine. Meaning what? As I go around the circle, or go into my quadrants, remember in quadrant 1, x and y are positive. But in order to get into quadrant 2, x has got to be negative, y has got to be positive. In order to get into quadrant 3, x and y have got to be negative. In order to get into quadrant 4, x is positive and y is negative. Now again, why is that important? Because if you can think of sine being y and cosine being x, it's very easy for you to figure out which trig functions are positive and which trig functions are negative as you go around the circle. So let's recap. My sine is y, my cosine is x. Sine can also be written, since sine is y, cosecant can also be written as 1 over sine. Secant can now be written as 1 over cosine. So as you see, whatever is true for sine will also be true for cosecant, and that's the reason why in quadrant 2, both of those are positive. Whatever is true for cosine would be true for secant, and that's why in quadrant 4, cosine and its reciprocal are positive. And whatever is true for tangent from a standpoint of sine over cosine, why is that? Because it's y over x. So sine is y, cosine is x, is y, sine over cosine, and cotangent is cosine over sine. So think about this. If I go into quadrant 3, for example, x would be my cosine, sine would be my y, so I'd have a negative divided by negative, which would give me what? A positive. So that's why in quadrant 3, your tangent and your cotangents are positive. Now, all of this information we're building in my next slide I'm going to give you, my next video I'm going to give you, we'll be talking about how to extend this further and hopefully figure out our exact trig function values.